Today we are going to
Yeah.
start the second chapter from wave section that is related to sound,
Yes.
right? Because we have four chapters in this section. One is general properties that we already done. Second one is the light. Light is the lengthy one. So we start with the sound and electromagnetic magnetic spectrum. So after that we left out with only one chapter that is of light. Okay. So that is the lengthy chapter.
Okay.
So starting
All
from the
right.
sound. So first of all, we need to know about that. What type of waves are going to be generated from the sound? Is it transverse or is it longitudinal?
Now, how can we tell the difference?
Uh, do you know the basic difference between longitudinal and transverse?
Yes.
Okay. So now if we want to consider sound waves, so what type of wave sound is? Is it longitudinal or transverse? We also discussed in the example. If you remember, this is your previous notes, and yes, here it is. So basically, sound is longitudinal in nature, right?
Right.
And the purpose of sound waves are also the same, to transfer energy from one point to another without transfer of matter, right? So first of all, the basic property of sound is that sound wave is longitudinal in nature. Sound wave is longitudinal in nature. And the second important thing is that sound requires medium to travel, right? Because if we consider
Right.
space or vacuum, so we know that sound cannot travel in space or vacuum, right? So sound
Mm-hmm.
can, and the next important thing is that we need to know about the speed of sound, right?
Sir, what does medium mean?
Medium means you need to require some source that help you travel from one point to another. So basically, medium means source. Let's suppose consider example of our daily life. So in our daily life, air is the medium, right? So air molecules help us or help sound waves to travel from one point to another, right? Okay, so basically medium means a source which help us to travel or which help to travel. So this is the concept of medium. So normally in our atmosphere, we know that there are multiple, or we can say that unlimited air molecules. So that molecules helps sound wave to travel from one point to another point, right? So that is called medium. Same like the
Oh, okay.
solid. If we strike some solid material, so solid material also have its own molecule and atoms. So that is a type of source, right? But in vacuum or in a space, you know that in space there will be no air molecules, so no sound is going to be transferred from one point to another. So that is the concept of medium, right?
All right.
Yeah. Okay. And next important thing is you need to know about this, because this chapter is very much as compared to one, and this is also very short. So the next thing we need to discuss is the speed of sound. So basically, how many types, or we can say that how many states of matter are there? Solid, liquid,
There
gas.
are three states in the
Yes,
solid liquid gas.
yes. So normally when we talk about the sound waves, so we discuss sound waves in air medium, right? But you know that sound will also travel in solid medium, or it can also travel in water medium, right? So let's suppose if we talk about the normal daily life example. So in our normal daily life example, we can say that uh, sound travels at speed of, what will, any idea?
No, I forgot.
So sound travels at the speed of about 340 meter per second in a room temperature, right? Why we are right room temperature? Room temperature means if we kept the temperature and the pressure of the air constant, right? Because molecules behave, or the behavior of the molecule depends upon the pressure or the temperature of the surrounding, right? You know that if temperature is high, so molecule has high kinetic energy, right? So it starts moving from one point to another. Okay, so that's why we are using the term of room temperature. Okay, so at room temperature, we can say that in ideal condition or in normal condition, in air, sound travels with 340 meter per second. But if we talk about the variation, so in air, the variation in speed of sound will be between 330 to 350 meters per second. This is the speed of sound in it, depending upon the different condition of air with respect to the temperature, with respect to the pressure. We are not going to discuss those effects specifically, because those are not included in our syllabus, right? But we need to know about that there will be a bracket of speed of sound that is between 330 to 350. Okay, so we calculate the average value, that is 340, right? And if we talk about the speed of sound in different mediums, so in different mediums, let's suppose if we first talk about three of them. So if we talk about the speed of sound in different medium, so we talk about, then we talk about liquid, talk about gas. Gas means same air, right? Okay, so if we talk about the solid medium, so solid medium means, what do you think, that sound will travel faster in solid or in liquid or in gas? Which medium helps sound to travel faster? In solid, liquid, or gas? So sound will travel fastest in solid, right? It will move with slower speed in gases, and
Wait.
in sound will move in every uh,
Yeah.
gas,
Wait.
right?
How?
I will also give you the reason that why sound travel faster in solid, not in gas or in liquid, right? First, I will write the values, so that will help you to understand that how much is the difference between solid, liquid, and gas. So if we just generally write the value, because in exam, if they ask you about the speed of sound in solid, so they ask like this, that write typical value for the speed of sound in solid, right? They will not ask you to write exact value, because that is not the part of our syllabus. If they ask about the value, that mark the typical value, so it will be like a range of value, not a specific fixed value, right? So you need to remember that in solid, sound travels with average speed of 1000 per second. So in solid, the speed of sound will be in thousands. And if we talk about the liquid, so in liquid, the speed of sound will be in hundreds. So liquid, it will be equal to t second. And in gas, you know the same, 330 to 350 meters per second. So these are the typical values. You just need to keep these values in your mind, not the exact number, just values of 10, like the speed of solid sound in solid will be in thousands. It may be 5,000, 6,000, depending upon the material, right? Because material also help us to transfer molecules faster or slower. Okay, is it clear till now?
Yes, it's clear.
Okay, now let's discuss the reason why sound travel faster in liquid as compared to, sorry, faster in solid as compared to other matter. So question is why sound wave travel faster in solid. So this is our main question. Now, if we talk about the basic formation of solid, liquid, and gas, right? So you already know about their formation. Solid has fixed shape and fixed volume, right? As compared to liquid and gas, solid has fixed shape and fixed volume. So molecules are tightly packed with each other, right? So let's suppose
Right.
if we consider the example of solid, so if we only consider solid on the side, the matter form of solid. So let's suppose molecules are tightly packed with each other, right? And let's suppose if you want to transfer energy from one point, let's suppose if you transfer energy from one to the other, right? The last one. So you can say that your distance is like negligible. So you can easily transfer your energy from first molecule to the last molecule, right? And in the comparison, if we take a liquid or gas, let's suppose if we take the example of a molecule. So in gas molecules, the molecules are far apart or in irregular pattern also from each other like this. Okay. Now, if you consider
Okay.
the situation that if you want to transfer energy from this left hand side to the right, see that one problem is that the pattern of the molecules is irregular. Molecules are distributed irregularly. And the second problem is that all molecules are not in a straight line or not in a fixed shape. So that is the problem, due to which sound waves can easily and faster travel in solid as compared to other medium. Okay, so this is the actual difference. So they also ask in your exam that explain with the reason, if state with the reason that why sound waves travel faster in solid. So your reason is in solid molecules are tightly packed with each, or we can say that molecules are close enough to each other. So transfer of energy will be simple and easier for the molecules of solid, right? Okay, any confusion? Because now you got the concept. So if you want to phrase answer by yourself, so you may also phrase your answer by your own. It's up to you, because you got the concept that what is the main difference. And we know that in solid, molecules are tightly packed, so they can easily vibrate and they can quickly transfer energy without wasting their energy in any other form. So that's why in solid, sound wave can travel more faster as compared to solid, as compared to liquid and gas. Okay, any confusion?
All right. No.
Okay. The next thing is, since we are talking about the wave section, so we know that if you want to calculate the speed of sound in different medium or in any situation, so we have to use the same formula, v equals to f lambda, right? So before that, our main topic is, okay, so let's suppose if we want to calculate or measure the speed of sound, right? Let's suppose practically you want to measure the speed of sound in your daily life. So what we need to do, right? So we want to measure speed of sound in our daily life practically. Okay. The actual value, that is the original value, but let's suppose if you want to calculate the speed of sound in your daily life, because that is not much very difficult, just like the speed of light, because the speed of light is like million times, or we can say that 10,000 times greater than the speed of sound. So that's why for speed it is difficult to calculate as compared to the speed of sound, right? Okay, so let's suppose if you want to measure the speed of sound, so we consider our apparatus first of all. Let's suppose we consider any sound source, right? Let's suppose we are taking, or we can say that
Is
one
there a
of the
specific formula?
formula. Yes, formula is the same, v equals to f lambda, that we already discussed in previous chapter. But sometimes they ask you to write the experiment that how to measure speed of sound. So you need to know about the apparatus, you need to know about the procedure, because you need to write in your answer, right? So let's suppose we are having a first person over here. This is our student one or person number one. And what is the purpose of this person over here? So there is, or we can say that we just use a stopwatch over here. So this person is having a stopwatch, and on right hand side we are having another person, right? And what is the purpose of the second one? The purpose of the second purpose person is to clap, right? So this is our part of
Oh,
experiment.
okay.
And two, or student number two or observer number two, right? So the main purpose is that the person two, which is standing at some distance from person number one, when he claps, and when person one receives the sound of the clap, he starts the stopwatch and then stop the stopwatch. So that will give us the time period during which the sound is produced, and the time when we hear the original sound of the clap, right? Any confusion?
No.
Okay. So first of all, what we need to measure the distance between two person, right? So this is our first main concern. We need to measure the distance between two person. So this is distance between two person, and first of all, we need to measure this distance, right? And how you measure the distance between two person? Distance using what? Which instrument are you going to use for to measure the distance? Any idea?
Huh? Oh.
Actually, you need to measure a distance between person, because we are experimenting on open field, open ground. So sometime we need to measure a long distance. So measuring instrument or meter ruler is not enough. You can also use a measuring tape, but I am adding one additional instrument that will also help you to measure the distance between two bodies, right? Okay. So trundle wheel is the new apparatus or the instrument that also help you to measure the long distance. It's just a wheel, and there is an electronic meter connected with it. So it works on the circumference of the circle, right? He count the circumference, then converts into the meter, right? Just like the roller on the field, we are using a roller on the field, so it also works like the same. That wheels a roll on the ground and it just measures the circumference and then convert into the distance. So you may also use
Okay.
the measuring tape or wheel, because we need to know about the additional instrument that help you to answer question different varieties. Or you can also measure with the help of measuring tape. And what will be your second step? Next step is that person two needs to be clapped. Okay. So person two using two blocks, right? Because that will produce a solid, because we are a solid. So person two claps using two wooden blocks, right? And what will be your next step? Any idea? Now person two just claps using wooden blocks. So what will be your next procedure? So your next procedure is that person one has a stopwatch, which start when he see the first, when he see the second person or person number banging the blocks together in the block and stops when he hear the sound. Okay, is it any confusion? A very simple, because the steps are very much important, because sometimes they ask you to write the whole experiment for 3 or 4 marks. So it is important to understand and to write the whole experiment by yourself. So that will help you to answer the final question in your exam, right?
Right.
And the final thing is what we need to do. So we measure the distance initially, and we calculate the time using the stopwatch. Then what will be your next steps will be like number 4, what we need to do. So we need to repeat this experiment several times, because we never take only one reading in this type of experiment, because there may be chance of error, because maybe we just start our stopwatch late as compared to the timing of that banging those blocks or the clapping of that person number two. So that's why we repeat the same experiment for several time, like 5 time, 10 time, 15 time. Then we find, take the average of all the values, right? So you need to repeat same experiment several time, same experiment several times, and take an value, take an average value. This will be our average time period, right? Then our final step is, finally you need to do what? You need to do use the formula. So use the formula final value of the sound, right? So your formula will be equal
Right.
to speed of sound on left will be equal to distance traveled, distance traveled by sound, okay, divided by time taken by sound wave, right? So this is the final formula. This is the experiment, a very simple experiment to measure the speed of sound in our daily life. Okay, any confusion?
No.
Okay, so this is a very simple experiment. We can also perform this experiment with different instruments, like we just take alarm clock and we measure the distance between alarm clock and our stopwatch, and we just uh, start our stopwatch when we saw that your time is completed over there, at which the bell is going to be ring over there of that watch or that clock. So that also helps you to find out the speed of sound, right? And let's suppose if you want to find out the speed of sound with the help of wavelength and frequency that we already studied in our previous chapter, so then you need to use the same concept, v is equals to f lambda, right? So your formula will remain same. V is equals to frequency times wavelength that we already discussed in our previous chapter, right? So that will give you a journal speed of wave. It may be any type of speed. It may be sound, it may be light, it may be electromagnetic, right? So we use this formula for the sound waves also. Okay. Any confusion?
No, sir.
Okay. And one more thing that we need to discuss today, that is the concept of echo. Echo means the reflection of sound, right? Let's suppose if you are in an empty room and there is nothing placed in the room, and when you start clapping over there, or let's suppose if you want start a scream over there, so you observe that your sound completely reflect back towards you, right? So you are observing or you are hearing your own sound, because there is no other person in the room over there, no other object is placed over there.
Like the sound bounces
Yes,
off back
sound
to me.
bank. Yes, that also happens in the mountainous area, right? That sound just come back with the same sound, with the same words that you repeated or that you say over there, right? So that is the bounce back of the sound. So that concept is known as echo, right? We also use that effect in the mic system or in phones also, that are sound repeated for the multiple times, right? Just like if we want to talk someone, so if we are using a microphone, so that sound will repeated multiple times. So that is the concept of echo, reflection of sound, right? So echo means reflection of sound, reflection of sound waves from the solid surface, right? Because solids, again, same concept, molecules are completely packed with each other. And in soft material, let's suppose if we are using liquid or air, so molecules are not completely packed with each other. So in that case, sound will not reflect back or not bounce back, right? Because solid will act like a rigid wall. Let's suppose if you just throw a tennis ball towards the wall, so it will bounce back. So same concept goes over here for the sound waves, right? And this concept of reflection of sound is known as echo. Okay, any confusion?
No.
Okay, and let's suppose if we want to use this concept in our daily life in practical application, so what are the daily life applications of this reflection of sound? So basically, we use this phenomena of echo in daily life, not in our daily life like this. We use the concept of reflection of sound. We use the concept of echo uh, in the ship or in submarines, right? So that will help you to detect any other device nearby you, just like the radar system in submarines, or just like the map of the ship. So that actually operates on the concept of echo, right? So you can use the concept of echo to measure the depth or to detect objects underwater, right? And normally we use a very simple formula: speed is equals to distance over time. But let's suppose you want to the speed or the distance, or let's suppose the time in the concept of echo. So your formula will be slightly different from the original one. Let's suppose if we are having a solid ball here and we just generate sound wave from the left hand side. So this is our source of sound. So what actually happens over here, sound first travel in the forward direction, then it will bounce back. Travel in the direction, then it will bounce back, right? So the distance will be, or the distance for the sound wave will be doubled. Let's suppose if the original distance from the center to the wall or to the reflecting surface is equals to 20 meters, is equals to 20 meter. So your final distance will be equal to 20 meter plus 20 meter, right? This is your sound source. And let's suppose if you want to find out the speed of sound or any unknown quantity over here. So for this concept, you need to increase the distance or just multiply the total distance by 2, because sound travels the same distance two times over there, right? He travels twice the same distance. So that is only the difference between the formula of echo as compared to the other general formula for the speed of sound. So your final formula will be equal to V represents you the speed, 2D over T, right? So this will be your formula. D represents you the distance, or the distance source and ball or reflecting surface. T represents you the total time, and V represents the speed or the sound, right? Any confusion?
No.
Okay. So this is a general formula to calculate the echo or to calculate any unknown quantity related to the echo. So this formula is especially for echo only, not for the journal terms, right? So this specific formula is only for echo. And if you want to calculate the journal speed of wave or the journal speed of sound in any medium, so you need to use this formula, the first one. The journal formula: speed is equals to distance upon time. Okay. This is much difficult. This is the basic and simple concept as compared to the previous topic, right? We also discussed the advanced application of the echo, because it also use in our daily life. The experiment of the ultrasound we also use in the ship to detect unknown objects under seawater. So that is also a practical application, but we don't need to study that in very much detail. We only discuss about the journal overview, because 99% questions are related to the formula of echo. So we only need to know about that formula, and we need to know about the concept that how echo actually works. Okay.